Recording in progress.
Let's start. Last week, we learned about using the power rule and the chain rule, product rule, and quotient rule to calculate the derivative, okay? This is the power rule. You have x to the power n. You put n in front and you do x to the power n minus 1. You have two guys product. You do u times v prime plus v times u prime. And for here, you want to remember this quotient rule. You do v square as the denominator. You do u times u prime, the numerator derivative times the denominator minus u times the v prime. This is the quotient rule. The other part, this guy is called the product rule, the chain rule. For the chain rule here, if you have trouble to do this, we can always think you make u equals to g of x. So it is doing fu, okay? It is doing fu. Y equals to fu. Y equals to fu. So if you want to get dy over dx, you are doing dy over du, and then du over dx. This is this guy. That is this guy, okay? You choose the out layer, get the derivative, and then you are going to do the inner layer. We also talk about the trigonometry derivative. Sine derivative will be cosine. Cosine derivative will be negative sine. Tangent derivative is secant square. Cotangent will be negative cosecant square. Secant, you go to secant times tangent. Cosecant, you go to negative cosecant times cotangent. All of this, you need to know how to do those, how this formula come from. And you also need to remember it, okay? Now, let's look at an application question. The question is saying, find a second degree polynomial. Now, this guy is a second degree polynomial. You don't know A value, you don't know B value, you don't know C value. This polynomial, you know for sure it's a parabola. Even if A is big, positive, it's going down up. If A is negative, it's going down. And this graph has a tangent line with a slope of 8 at the point -1, -10, and an intercept of 0, -5. Now, given this condition, they ask you what's your A and B and C value. Without calculus, this question is impossible. How do we do it? They said this guy has a tangent line with slope of 8. So you can do this guy. How do you get the tangent slope? You are going to do the f prime. F prime x will be A times 2x plus B. C is a constant, that's canceled. So f prime x equals to 2ax plus b. This slope is 8. So you make at the point. At this point, your slope is 8. So you are going to plug in -1 into x. -1 plug into x, this becomes to -2a plus b equals to 8. Equals to 8. This is the one equation. You have A, B, C, 3 variables, one equation. You are not able to solve your A, B, C. So let's look at the other condition. This guy also has the intercept of 0, comma, -5. So you plug in 0 here. A times 0 squared plus B times 0 plus C go to -5. So this is gone. C is -5. This is still not enough to solve your A and B. But you notice that this point is on this graph, okay? This is saying you have this curve. And at this point, your tangent line slope is -8. So this point is on your curve. So you can definitely plug in this point into here. -1 square is A, -1 square is 1 times A is A, minus B. C is already given. So A minus B plus C equals to -10. So A minus B will equals to -10 minus C. C is -5. -10 minus -5 is -5. Now you have A minus B go to -5. You have -A plus B equals to 8. You can solve your A and B value. So let's summarize the steps, okay? Step 1, get the constant value of C. Step 2, based on the slope equals to 8 at this point, you find the F prime, and then you plug in -1 into here. This slope is 8, so you make -2A plus B equals to 8. This is step 2. Step 3, this point is on the curve. You are going to plug in the X value here and equals this Y value. This is step 3. Step 4, you are going to solve your A and B in this system linear equation, and then you get your ABC value. So what does this look? This looks like this. After we solve the A equals to -3, B is 2, C is -5. This is a problem like that. And then you can plug in, you can say the tangent line pass -1, -10. That means you can use the point slope format. Y minus -10 equals to 8 times X plus 1. So Y equals to 8X minus 2. You can write down this function here. And you can mark the point -1, -10. This is the point -1, -10. So this shows that our solution is exactly correct. This tangent line connect with this parabola at -1, -10, okay? And that's the tangent point. That's what's going on. Now, for the AP test or your quiz or your major test in your school, sometimes you have this kind of application questions. Let's do one more. They ask you find A and B so that F is differentiable everywhere. We know that differentiable has to satisfy two things. Number one, you have to be continuous. When you draw your graph, what is continuous? This is called continuous. When you draw the graph, you don't need to lift up your pen, you can finish drawing. It's called continuous. This is also continuous. But this guy is differentiable everywhere. This guy is differentiable everywhere except this point. What happened here? The slope on the right is going this direction. It has a positive slope. The slope this direction is like this. That point is called continuous but not differentiable. The derivative at this point does not exist. This point is called cusp, C-U-S-P. This is a cusp point, okay? So you want to pay attention here. This guy, you make sure you know this point is not differentiable, okay? Now let's see here. Next one. This question is the first time you see the second derivative. And what does second derivative means? Second derivative means you are going to do the derivative for the first one, okay? Example here, y prime plus 3y equals to 2. And the 5 times y double prime minus y prime. In an equation, when you have your x and y prime, this is called differential equations. And this is the first time you see this name, differential equations. And they ask you to verify that this guy satisfies the differential equation. This looks complicated, but as long as we use everything we have learned so far, it's not hard. Let's do it together, okay? I'm going to call a student to do with me. Aiden. Let's see here. This is the y. How do we find out y prime? Y prime is?
Y prime is 6x minus 2.
Very good. Y double prime. Y double prime means you do y prime's prime. So let's do the, this guy derivable is how much?
Y prime's derivative is 6.
Yes, this guy is 6. This guy is 0. Okay, so this equals 6. Very good. Now let's see x squared times y double prime minus xy prime plus y. This equals to x squared times who?
6.
Minus x times
6 minus 2. 6x minus 2.
and then plus y
3x
is this.
squared minus 2x.
Let's put this guy over here. This equals 6x squared minus 6x squared plus 2x plus 3x squared minus 2x. This canceled, that canceled. So this is a 3x squared, right?
Yeah.
So in this way, we prove that this one satisfies this differential equation, okay? Yeah. Now you may wonder, you may feel curious, can I solve this one? Okay, and solving the differential equation is not easy. We will learn to solve differential equation after 10 more classes, okay? This guy is the hard level. This is in the second part of calculus curriculum, okay? Right now, if they give you a function, you can check if this is a correct answer. But if you don't know this, you want to solve this guy, it is really hard. Next one. This is called something called a rate of change question, typical rate of change question. Let's see here. I'm going to call a student to work with me together, okay? Is there any volunteer? No volunteer? Angela. Let's do this together. The radius is 2t. The height is this. Cylinder. What's the volume for cylinder?
It's pi r squared h.
So this gave me 4 pi t squared times this, right?
Yeah.
Okay. Now they ask you, find the rate of change of the volume with respect to time. You may feel strange because you never see these words before. Rate of change of the volume with respect to time. This guy is basically asking you dV over dt. This is asking you dV over dt. Okay, rate of change of volume. So they ask you the change of your volume with respect to time. So this is dV over dt. Which rule you want to use to solve this guy? Power rule or quotient rule or product rule? Which one?
Product group?
Yes, we can do the product rule, okay? We are going to write down 4 pi times t squared times square root t plus 1. So we copy down this. We do this guy derivative times this plus this guy times this guy derivative. Let's go. So this is a 4 pi times t squared derivative is
2t.
2t. And then you copy down this, right?
Yeah.
Plus
t squared
times
1/2.
yes.
T plus 1 in parentheses.
T plus 1 to the power of what?
To power negative 1/2.
Negative 1/2. It is because this is this. When you do the power rule, you put 1/2 and then this guy to the power of 1, negative 1/2 minus 1. Okay? And t plus 1 derivative is 1, right? So you don't need to write down 1 here. If I have a 2 here, then you need to times 2. Here is 1t, so you just times 1. You can ignore it, okay? That's it. That's the rate of change of the volume with respect to time. Even this is so long, it is just asking you the V prime. Now, we are going to do some more complicated chain rule questions. Okay, I need to make sure every student master the chain rule, okay? Clear. Let's choose a ugly one, okay? Let's look at this guy. This guy looks really ugly. Like this. This one is really ugly. So we will take care of this first, right?
You move it down so it's
Okay.
40.
So don't feel scared. When the question looks really complicated, don't feel scared. If you feel scared, you will not able to do it. You put 4, you drag the 4 here, correct? And then you copy down this whole package, right? Yes.
Yes.
4 was put here. Everything else is copied down exactly. And then change this 4 to 3. And then you want to times this guy derivative. Make sense?
Yeah. So
So we want to say, who is this guy derivative? Yes? So you put this on the top. Who is this guy derivative? Look, that's a constant. The derivative of this guy is 0. You can let it go. And then you are going to put negative, right? So we will put negative. This is 3. So you put 3 here, yes?
yeah.
And then you are going to do 2 plus x plus 3 square. And then 3 minus 1 is 2, right? correct? So far, so good, Claire.
Yeah.
Now, you come to here. But the problem is, you did the derivative of this package. You buy, this is 0, so you have a negative here, you put a 3 here, and you got here. And then the inner layer, you take care of this guy, and the next layer is this one. So you want to take care of this guy's derivative. You want to do this guy's derivative. This guy derivative, that derivative is 0. This derivative is 2 times x plus 3 to the power 2 minus 1. Okay, that's it. And then you want to say, can I also do this guy? Well, x plus 3 derivative is 1. So you can just stop here. That's all. How many layers it has? 1 here, 2 here, 3 here. 1, 2, 3. Not too much. You feel better now? Claire, can you do this by yourself now?
Yeah.
Okay. Now let's do the next one. Cindy,
Mhm.
let's see which one you want to start.
Okay. Okay, so I know that derivative, like the derivative of sine x is cosine x.
Very good. So we write down cosine,
Yeah.
and then we copy down here.
Mm-hmm.
Okay.
Yeah.
And then what we do next? We are going to treat this guy, right?
Yes.
Yes. We are going to do this guy. Sine derivative is cosine. And then we are going to take this guy derivative. Who is this guy derivative?
Oh,
You times 1/2, right?
yeah.
And then 3x cubed minus 4 to the power of,
-1/2.
yes. Are we finished?
Mm,
We want to do this guy derivative, yes?
yeah.
This guy derivative is,
9x squared.
yes, that's it.
Okay.
Okay, yeah.
Mm-hmm.
Now the next one. The next one is kind of very tricky, okay? Let's see here. F3 is 2. G3 is 4. F4 equals -6. F prime 3 is -7. G prime 3 is -5. F prime 4 is 8. Wow. So ugly. I don't know what they are doing now. Hx is a composite function, which is f of gx. And then find h prime 3. This is exactly chain rule. H prime x equals to, do the outlier, f prime of gx times the inner one, g prime x. So we will use this formula. So h prime 3 equals to f prime of g3. 3 is replaced here. 3 is replaced here. G prime 3 is given -5. G3 G3 is given 4. So G3 was replaced by 4. This becomes to F prime of 4. And G prime 3 is -5. Copy down -5. G prime 4 is 8. 8 times -5 equals to -40. Okay. So chain rule not only can be applied to a function, but also can be applied to a table. Okay. If they give you a table or a list, you can also get your derivative. Okay. So far, any questions? If you feel this part is hard, you have to practice again and again. After my class, I send out the video. You have to check out the videos. Make sure you truly understand and being able to do every single question by yourself. Next one. Lawrence.
Is it J or is it I? Oh,
I. Okay, let's do the I together. We might rewrite this first, okay? We can rewrite this to be secant. Okay, so go ahead, please.
So first we do the outside, so we put the squared, I'm pretty sure, and get right in that spot, and then copy everything else down as it is.
This is the first layer, right?
Right.
2 put here, 2 minus 1. Who is the second layer?
The S is a sector, I think.
Yes, secant. Who
then-
is the secant derivative?
Is it tangent and then SC sector times S sector? Yeah.
Tangent times secant. So if you copy down this, if you see secant
Secant.
times tangent.
Tangent. Okay.
Okay. Are we finished?
We're not finished. We still have the 4x cubed plus 5.
Okay. This guy derivative is?
It will be 12x squared. It's just 12x squared.
Yes. That guy is 0. Okay. Times 12x squared. Okay. Yeah. Very good. You do very good. Thank you. Now, let's see who else. Olivia.
Okay. Which one?
H.
Okay. So first it would be 4 and then times, yeah, and then times cosine 5x to the third.
Okay.
And then it would be negative sine 5x. And then times 5.
That is perfect. Very good. You made it. Thank you. Zhao Yuchen. Let's do the G. Look at this. What we do first? This guy derivative equals
7x.
This is going to be negative cotangent times cosecant, right? Right. So we want to use this formula first, right?
Yeah.
Go ahead.
And we can put 7x, 5 put in the copy down, go in the blanks.
We put here.
And the time cotangent, copy down, and the time 35x. 35x. And 4.
Really? Huh? To the power 4, right?
Yeah, and power 4.
That's it. We do this guy. This is negative cotangent times cosecant. And then this guy derivative will be 35x to the power 4. Okay, that's it. Yeah, we stop over here. Yeah, I think other question. Well, this is not hard, not hard. Let's try a question for this one. This one, I'm going to use two different ways. We can do the product rule. We can also do the quotient rule. Okay. Who want to do number D with me together? Any volunteer? No volunteer? Hayden. Look at this. You want to do the quotient rule or you want to do the product rule? Hayden? Hayden, can you hear me? Lawrence, let's do the D together, okay?
Okay, that's fine.
Okay. So we want to do this guy. 5, we can leave it outside, okay? Yeah. We rewrite this. We change
right.
this to that to the power negative 1/3, okay?
Okay.
And then we can leave the 5 outside.
Mhm.
We can leave the 5 outside.
Right.
This guy derivative is
X derivative is just 1.
very good. Times, copy down this, right?
Copy down all that, right?
Plus,
Plus, and then we do the, I'm pretty sure it's just a negative 3. I have to move that one out.
yeah, let's copy down X first.
Oh yeah, X. Oh yeah, product
Times,
rule. We keep that one, right? And
times
then we do negative 3.
negative 1/3.
No, sorry, negative 1/3. Yeah.
Negative 1/3.
Mhm.
Times
X squared plus 2 to the power of negative 4/3.
okay. Times,
And times we gotta do the more inside one. So it would be like, it was 2x.
that's right.
Just be 2x. Yeah.
That's it. Okay. Yeah. So
Okay.
this is called product rule. Let's give a try for the quotient rule. Okay.
Okay.
The quotient rule looks a little bit complicated, but we still want to master the skill.
Mhm.
Let's go ahead. G prime X equals. You want to do this guy square, right?
That one squared.
So we are
Oh, yeah,
going to write down
yeah.
this to the power of 2/3, correct?
2, 3. Yeah.
Okay.
Same.
And then this guy derivative is who?
It's just 5.
Very good. Copy down the bottom,
Yes.
that, right?
Right.
And then plus 5x times,
Times. Is it a negative 1/3, or do we keep it as 1/3?
you choose this as 1/3. Okay.
Is 1/3? Oh, okay. Okay.
You choose this as 1/3. You ask a very good question.
Okay.
If you do the product rule, you treat this as negative 1/3. If you do this guy as the quotient rule, you choose this as positive 1/3. Okay.
Okay.
So at 5x times
5x times, and that's 1/3, and then you copy everything down, x squared plus 2, and to the power of negative 2/3.
very good. 1/3 minus 1 is negative 2/3. Okay.
Okay.
Yeah. And we can check. Look, this guy. Yeah, we can do this to see if they are exactly the same. Let's go. That equals to 5 times
5 times x squared plus 2 to power of 1/3, negative 1/3, yeah.
this minus this is negative 1/3, right?
Okay.
And
Okay.
then let's do here.
And then that plus 5x, and then times 1/3 with negative. No, it's not negative.
Oh, here. We have a typo. The quotient rule is we need to put a minus inside here, right?
Oh, yeah, minus, yeah.
Yes.
That's my bad.
Next.
It'll be 1/3, pretty sure, times. And you just copy that x squared plus 2, yeah. To the power sets that flips up, so that's -4/3. Do you also
Okay.
put that negative there as well for the 1/3? Or no, it's actually copied down. Never mind then.
Mm-hmm.
Okay. I
That's
see.
correct. Correct.
Mhm.
And
Yeah.
here we miss this guy. This guy also a 2x, right?
Oh yeah, and a 2x, right?
Because when we do the quotient rule, we do the denominator square, and
Mhm.
then the top one derivative times the bottom one copy down minus the top one copy down. The bottom one derivative is 1/3 x squared plus 2 to the power of 1/3 minus 1, which is -2/3.
Yeah, we also
And
have to
then
put
this
the
guy
inside.
derivative is 2x.
Yeah.
Okay.
Mhm.
Yeah. Let's check here. Phi. Yes. This guy and this guy match.
Mhm.
This guy match. Negative here, negative here. 1/3 match. -4/3, -4/3, 2x. So both way are correct.
Why
But
is
I do think, mhm,
why isn't there a 5 in the first equation?
because this is phi put outside.
Oh, put
This
outside. Oh, you
this is the same.
okay. Never mind. Then.
Okay. Yeah. But I do think the product rule is way more quicker, right?
Right.
Okay. Yeah. So sometimes if you have complicated quotient like that, I suggest you change it to the product so that you can do it quicker. Okay.
Okay.
Yeah, very good. You do very well. Well, I think other question is not hard. Y'all can handle it by yourself. We are going to move on to a next worksheet, okay? This one, we do have some more hard questions. And I need to go back to all the different rules, okay? Let's see here. We learned about definition of derivative. And based on the definition, we found out the sine derivative is cosine. And we use our trigonometry foundations to find out cosine derivative is negative sine. And then we also learned the chain rule, product rule. We even derive how the product rule comes from. Power rule. We even also shows how the quotient rule comes from based on the product rule. After we know the product rule, we can also do this to find out the quotient rule. When we know how to do the quotient rule, we find out the tangent derivative is secant square. Okay. Now, we also derived the cotangent derivative, secant derivative. This is how those formulas come from. You need to be able to do this and remember the conclusion. Cosecant derivative. For the inverse trigonometry, it is too hard for now. We will hold it until next class. Now I'm going to teach you the e to the power x. Okay, we haven't learned the exponential rule yet. E to the power x derivative u equals how much? There's no rule for us to use here. We have to start from the definition of derivative. From the definition of derivative, we know that this is, let's copy back the original definitions. The original definition is over here. definition of derivatives is critically important, okay? Everybody, you have to master this. So we will use the definition to find out e to the power x derivative is how much. We do e to the power of x plus h minus e to the power x over h approach to 0. You can extract e to the power x. And then you have e to the power h minus 1 divided by h. Well, this part, you don't know what it is. What we can do now, we have to use the graph calculator, okay? You might wonder why we always have to do some graph calculator. It is because we haven't learned the L'Hospital rule yet, okay? Without the L'Hospital rule right now, if we want to find out those guys' derivative, we can only use the graph calculator. So what we do is we do e to the power of x and then minus 1 and then divided by x. When x go to 0, it's going to be undefined, but the limits is going to be very close to 1, okay? Yeah. So you can see the limits when x go to 0 and x equals 0, okay? Their crossing point, the limits approach from the left and the limits approach from the right equal, and it's equals to 1. Even though at the x equals 0, the function itself does not exist, but the limits there exist, which is 0, okay? Which is 1. So that guy go to 1. So this is 1. E to the power x times 1 is e to the power x. Now we are going to use this conclusion. E to the power x derivative is e to the power x, okay? Now, not always if you were given an exponential function, it is use the base of e. They can choose any number like 2 or 5 or 3. So what's the general formula for a to the power x derivative? We are going to manipulate. We are going to manipulate with the thing we have learned in algebra 2 and the pre-calc. A to the power x. Look at this. A to the power x is e to the power of ln a to the power x. If you don't remember who is ln, ln is a natural log, which is log e, okay? ln is log e. So if you have this guy and this guy equal, these two will cancel. A to the power x equals to a to the power of x, okay? If you still feel confused here, let me show you this. You can say log e a to the power of x. You can say a to the power x equals to a to the power x. And you can say log e a to the power x equals to log e a to the power x. These are identical. You choose the same log. This is also identical. And then look at here. If you want to keep this guy here, you want to move this guy to this side, you are going to treat e as a base. You are going to treat this as your exponent. So that can show e to the power of log e a to the power x equals to a to the power x, okay? these two equal, and then this guy is e to the power of this whole thing. Okay. So based on this, we have a to the power x, a to the power x equals to e to the power of log ea. You can write down ln, okay? Log e a to the power x. This guy, we can use another log rules, okay? Log properties. You can put the x in front. So this becomes e to the power x times ln a. Yeah. If you feel this part is really hard for you, you really don't understand, you have to go back to your algebra 2 or your pre-calc, the logarithm part. This is calculus class. I'm not able to spend the whole class for teaching the logarithm and exponential again for the whole class, okay? You have to catch up that thing by yourself. A to the power x equals to this. Now, I want to do a to the power x derivative. We have this guy here. I will copy down here. Angela, let's do the derivative for here. Based on this guy, derivative is this guy. How do we write down this equals?
As limit of the h approaches 0.
This is going to be e to the power x times ln a, right?
Yeah.
But remember the chain rule. This guy is not x. You want to do this guy's derivative. This guy derivative is who? X times ln a derivative is ln a. That is the coefficient. Just like 3x derivative is 3, okay?
Okay.
So you want to write down ln a. Now who is this guy? Who is this guy?
That's a power of x.
That's a to the power of x. This guy is exactly a to the power x. So that's it. If I have 3 to the power x, I want to do this guy prime. That is 3 to the power x times ln of 3. Okay, that's how we apply this formula. Now, so far, is there any questions? No question? The more question you ask me, the more clear you get it, okay? Now, let's do y equals to ln x, okay? We have done e to the power x, derivative is e to the power x. We want to do the ln x derivative. We are not able to do this guy derivative. It is really too hard. What we do, we rewrite this. Y equals to ln x, that means e to the power y equals to x. E to the power y equals to x. And then you do this guy derivative. Cindy. E to the power of y derivative is who?
E to the power of y.
Times y is not x, so you want to do the chain rule. So it's y prime, right?
Yeah.
And then on the right, x derivative is how much?
1.
So y prime equals to 1 over e to the power of y. Make sense?
Yeah.
E to the power y equals, this
Mhm.
equals to x.
Yeah.
So 1 over x. Does this make sense?
Yes.
Okay. Now let's do log ax. Does anyone remember the base change rule? Does anyone still remember the base change rule? Log ax equals who remember the base change rule? How do I rewrite this one?
Isn't it like log x over log a?
You do ln x over ln a, okay? Or you say log ex over log ea, which is ln x over ln a. And now it is easy to do this guy, right? Clear, let's do this. So y prime equals to ln x derivative is 1 over x. And then you have this guy in front as a coefficient. So you are going to times 1 over ln a. Make sense?
Yes.
Okay. Now, with this, we are going to look. The formulas, you have to know why it comes from and the conclusion. So I'm going to highlight the things you need to remember, okay? What kind of thing is needed? That guy, definition of derivative. Sine x derivative equals to cosine x. Cosine x derivative is negative sine x. Chain rule. Product rule. Quotient rule. Tangent x derivative. Cotangent x derivative. Secant x derivative. Cosecant x derivative. We will hold the arc sine, arc cosine, arc tangent, arc cotangent, arc secant, arc cosecant into the next class, okay? The inverse trigonometry derivative will be even more complicated. We will hold it to the next class. This class, we also need to know that e to the power x derivative is e to the power of x. A to the power x derivative is ln a times a to the power x. And then we also found out that ln x derivative, ln x equals to 1 over x. And then log ax derivative equals to 1 over x times 1 over ln a, okay? All those yellow highlighted, you have to know how it comes from and what's the conclusion so that you can work out the hard questions. Now let's look at the questions. Now, again, this is the chain rule. We already practiced several times. I don't think everybody should have any question. This is also easy. Let me try to see if student can do this one correctly. Number 18. Olivia. Number 18, go ahead.
Okay, so
We can look, we can rewrite this guy. as negative t squared minus 5t plus 4 to the power negative 1, right?
Yes.
Okay. Power
Um,
rule first.
okay, so -1 times negative t squared minus 5t plus 4 to the power of -2.
Very good. Now we want to do the inner layer derivative. Who is this guy?
-2t minus 5.
That's it. You made it. That's it. Yeah, this is the final answer. Very good. Thank you. Angela, let's do number 28. You want to use the quotient rule or you want to use the product rule?
I can use the product rule.
Product rule. If you want to use product rule, we won't rewrite, okay?
Okay.
To the power of?
-1/2.
Okay. So y prime equals?
Equals 1 times x power 4. You just copy it now. So x power 4 plus 4 power -1/2. And then plus -1/2.
Get you to x?
X times -1/2. X power 4 plus 4 to power -3/2. And then times 4x to the power 3.
Okay, that's it. Okay, yeah. So product rule is better than quotient rule for the most time, okay? All right, this is easy question. Easy question. Let's see number 58. Lawrence, let's do number 58.
Okay.
H prime equals?
H prime equals itself.
We want to treat this as a power rule first, right?
Power rule first. Okay. That's to the power 2. But you can rewrite it to the power 2. And then you can, I'm pretty sure you can just move that down there. So it'll be like 4.
Yes.
2 times 2 before, yeah. 4 and times everything copy down, but to the power of 1.
Okay.
Times, and then you can do negative, I think, was it negative? Negative s cosine, I'm pretty sure.
Cotangent will
Cotangent.
derivative will be negative cotangent times cosecant, okay?
Okay.
So times negative
cotangent theta, and then
pi
times
t
pi t plus
plus 2 times cosecant
cosecant.
pi t plus 2, right?
Right.
And then times this guy
Times-
derivative is?
Pretty sure it's just, was it? I'm pretty sure it's pi.
Very good. This guy derivative is 0. This guy, you take the coefficient as it, okay? That's the
Okay.
final answer. Yeah. Okay. Now we are going to do derivative at given point, okay? Now let's see here. 68. Zhao Yuchen, let's do 68.
Okay.
Yeah, we can rewrite this first. Go ahead. What I write here? -2 pull to the front times, go ahead. Power rule, right?
Yeah.
How much? What I read here?
Copy down x of
To the power of
-3 and
times.
time 2x minus 3.
Okay. Now let's plug in, okay? X equals to 4. So this is the 4
16.
squared minus 12, right?
Yeah.
And then 2 times 4 is 12. 12 minus 3 is 9, yes?
Yeah.
Okay. This is how much?
1 divided by 4 power 3.
So this is 16, right?
Yeah.
16 minus 12 is 4. So this is a negative 60. This is 1 over 64, right? Because 4 to the power 3 is 64, right?
And time
And then times 9. This can be simplified as this. Correct? Okay. Thank you. Next question. No volunteer? Any volunteer? Cindy, let's do 79. F from X equals
F prime x is 2 times tangent x
times
times
who is this guy?
secant squared x.
Very good. That's it, right?
Yep.
Let's plug in X equals to pi over 4. How much is tangent pi over 4?
Tangent pi over 4 is, I think it was 1.
It's 1. How much is secant pi over 4?
2 root 2 over 2, just root 2.
Square root 2.
Yeah.
Because cosine pi over 4
Yeah.
is square 2 over 2.
Yeah.
And then square 2 squared. This equals
To 4.
Okay. Now let's do the point slope format. Go ahead. How do I do the point slope format? Y minus
Y minus 1 is equal to 4 times x minus pi over 4.
Okay, that's the equation of the tangent line at this given point. Okay, yeah, you might wonder, is this really true? You can double check. You can check, say, I'm going to draw a tangent line. I'm going to draw a tangent X. And then I'm going to make Y equals 4 times X minus pi over 4. And then you plus 1 on this side. Okay. And you can see here, it is tangent. Hold on, what's going on here? Oh, we draw the wrong tangent x squared. I need to put this guy. Yes. So you see here, it's a tangent point, right?
Yes.
Correct.
Mhm.
Yeah, you see, yeah, this is a tangent point. That's right. Now we want to do the second derivative. Okay. Let's see here for the question over here. Lawrence, let's do a question here.
Okay.
Sine x, you put a parenthesis outside, is the same way as you write square over here, okay?
Okay.
But if you have a sine x squared, if they write down this, that means you do the x squared first, and then you do the sine.
Okay. Right.
This is the same, this is the same, but this do not equal, okay?
Mhm.
So how do we do this guy derivative?
Well, I know it's cosine. Sine derivative is cosine. First derivative, yeah. Cosine, and then you copy down x squared. If you want to do the second derivative, and then you can do it, yeah, x squared would be 2x inside.
Okay, that's it. Now we
Okay.
want to do the product rule, okay?
Product rule, okay. 2x
F
plus
double prime, which means we are going to do the derivative for this. Let's put 2 out, and then we do the product rule. Go ahead.
and I know it just x regularly is just 1, and then it will be times the negative sign. Oh no, you don't need to do that. Okay, never mind. No, you don't need to do that right now.
Plus,
And then plus, oh, okay, and then you do x, move down the x, and then it'll be times negative sign x squared.
times,
And times you gotta do the inside of x, so it'll just be 2x.
okay?
Okay.
That's it, okay? That makes sense.
Okay.
Now, second derivative is not hard. When they ask you this, you are going to do the derivative for this one, okay? Yeah. When we learned the calculus BC part for the second semester, we will learn those Taylor series and the Maclaurin series. We will do the nth derivative, okay? Yeah. So it's not hard at all for this time. It's going to be really hard later.
Oh, okay.
Now, Aiden, let's do this question.
Okay.
We want to find out h prime 3. H prime 3 equals to
It's f of g. G of 3.
Fg3. That guy's derivative, right?
Yeah.
So we use a chain rule. We put the f prime here, right?
Right. F prime
And
g of 3 times g prime 3.
like that, yes?
Yeah.
Now let's find out the G3.
G of 3 looks like it's 5.
G3 is 5.
Yeah. So it becomes f prime 5 times g prime 3.
Okay. And the G prime 3, the slope here is how much?
Looks like 1.
Rise over the round, that's 1. We times 1. Now we want to find the f prime at 5.
The slope there looks like 1/2.
Very good. That's it, right?
Yeah.
Okay, now let's do s prime of 9. This is g of
F of 9 derivative.
Okay,
Yeah.
so we want to do g prime of f9 times f prime of 9.
Yeah.
f9,
F9 looks like 8.
Okay. F prime of 9.
F prime of 9, I think that's 2.
Okay. G prime.
G prime of 8.
The derivative slope.
That's -1.
Okay, -1. So this is -1 times 2 is -2, right?
Yeah.
All right, we finish. Very good. Thank you. Now let's look at that thing. We have to know that ln x derivative is 1 over x. Okay. Angela, let's do this. G prime x equals
2 times 1 over x squared
times
times just 2x.
the outer layer is this. So you can put this whole thing on the denominator. And then this guy derivative is this.
Okay.
X squared, you can change it to 2 over x. That makes sense?
Yeah.
Okay. You can do one more, number 2. Y prime equals
equals 4 times 1 over
4 times what?
1 over x.
No. This time the layer here is somebody to the power of 4. You copy down this, you change 4 minus 1. This is 3. Correct?
Oh yeah.
Times?
Times 1 over x.
Yes. You want to see the order. This guy, the outer layer is ln, so you do this first. This guy, the power of 4 is out, so you do this guy 4 times this guy to the power 3. And then this guy derivative is 1 over x, correct?
Yeah.
Olivia, let's do number 3.
Okay. Is it 1 over x times square root of x squared minus 1?
Okay.
And then it's times x times.
You want to use the product rule now.
Yeah.
You put this guy on the denominator, and then you are going to do this guy derivative. This guy derivative will be x derivative, which is 1 times this guy copy down, plus this guy copy down times that guy derivative.
Yeah.
Okay. So.
Okay, so it's 1 times square root of x squared minus 1 plus x times 1/2 times x squared minus 1 to the negative 1/2.
What
and
else?
Times 2x.
Very good. That's it. Okay, you made it. Very good. Lawrence, let's do number 4.
Okay. I know for this you have to do 1 over, I'm pretty sure,
Yes.
1 over x plus x squared plus 1, but you can flip that around to x squared.
Okay.
Plus 1, and then x, yeah.
Okay.
And I know you can do inside, I think everything in the bottom is to the power of -1, and you can do that 1 times x.
You make this guy flipped. That's right. And then we will do this whole thing's derivative, right?
Okay. Oh,
Yeah.
okay.
We can use the quotient rule directly. And this time we can use the quotient rule.
This time we can use it. Okay.
For the quotient rule, we will put this guy square on the denominator, right?
Right. X squared plus 1, that's squared. This will be x. Oh no, we won't solve it yet. I'm gonna wait.
This guy derivative is
It's just 1
times
and times x squared plus 1. And
minus.
you subtract, yeah, and then you can leave the x. No, sorry. 2 is just 2x times x.
Look, the denominator square, leave there. This guy derivative is 1 times this guy, copy down. And then minus this guy, copy down.
Right, x.
And then this guy derivative is
2x.
good.
Yeah, 2x.
Okay.
Okay.
And then since we take care of this in one step by the quotient rule, that's it. Okay, we don't need to do any further thing. We just stop here, but we can simplify.
We can simplify, right? Plus
Yes.
1 over x.
That is x squared plus 1 minus 2x squared. So this is x squared plus 1 minus 2x squared gives you 1 minus x squared, right?
1 minus x squared, right. All over will be, yeah.
That's it. Okay.
Okay.
Yeah, if you want to write down this in one step, 1 minus x to the power 4, right?
Yeah.
Because a plus b times a minus b equals a squared minus b squared. 1 squared is 1, x squared is x to the power 4. Okay?
Mm-hmm.
Yeah, that's the final answer.
Okay.
Okay. Clear. Let's do number 5.
Okay. So if I were to do the derivative of ln t, is it 1 over t?
Yeah, we can do the quotient rule first.
Oh, okay, we can do that. So for quotient rule, then it'd be t squared times 1 over t minus.
Okay. So ln t derivative is 1 over t times t squared minus.
Minus ln t times, that'd be 2t over t to the power of 4.
Okay. So this means t minus 2t times ln t over t to the power of 4, right?
Yes.
Cindy, let's do number 7.
Okay. Okay, so first
We can flip this first, right?
Yeah. Let's just root x minus 1 over x plus 1
Times
half times x plus 1 over x minus 1 to the power of negative a half. Then you do the quotient rule.
yes.
Yeah. So x minus 1 squared on the bottom, and then on the top is x minus 1 minus.
Because this guy derivative is 1, and then
Mhm.
times this guy, which is x minus 1.
Yeah.
And then minus
X plus
this
1.
guy times this guy derivative, which is 1. So minus x plus 1. Okay?
Yep.
And we can copy down that. Because I have to flip this for the top and bottom, right?
Mm-hmm.
Okay. Okay, yeah. Because this represents the square root, and -1 means you flip your numerator and the denominator to be like that.
Yeah.
And how much is this?
That's just -2.
Okay, -2.
So then you can cancel it out with the
Okay.
half.
This can be canceled out.
Yeah.
And then x minus 1, x plus 1, right?
Mm-hmm.
Over x plus 1, right?
Yes.
Because this guy and this guy. But the problem is, this will make sure it is positive. This also make sure it is positive. So when we take out this square root, we want to keep absolute value because we want to make sure this is positive, right?
Yeah.
So we want to leave an absolute value here, then times a -1 over x minus 1 square. Okay?
Yep.
Okay, very good. Next question, number 8. Students, if you think the question is too hard or if we go through too fast, text me a message, okay, in the chat window. Number 8. Angela, let's do number 8.
Okay, so you can flip it first, right?
Okay.
So then it becomes x over root 4 plus x squared.
Okay. Times. We can do the quotient rule, right?
Yeah. So then you can do the bottom is x squared.
Okay.
And then it's 1/2 times 4 plus x squared to the power of -1/2 times x minus root 4 plus x squared times 1.
Okay, like that. Now we can do some simplifications. This guy and this guy can cancel, right?
Yeah.
And then look at here. This and this is going to make it to be a 1/2 4 plus x squared to the power -1 times x, right?
Yeah.
Okay, -1/2 minus 1/2 becomes -1. X is copied down. And then minus. Does this two cancel?
Yeah.
This two cancel, so -1 over x, right?
Mm-hmm.
Okay, that's it. Make sense?
Mm-hmm.
Okay. Now, let's take a look at, let's do number 12, okay? Let's do number 12. For doing this one, you can use the quotient rule, but it's a little bit slow. I want to change this question a little bit. I change this to 1 minus 1 over this. Look, 1 minus this is the same as this because this guy can be read as 1 plus e to the power 2x over 1 plus e to the power 2x minus 1. This canceled. So they are equal. So y prime will be this guy derivative, which is negative, which is 0. So y prime equals to this guy derivative is 0. And then you are going to do this guy. This is negative times negative 1 plus e to the power 2x to the power negative 1 minus 1, which is negative 2. And then times this guy. You are using the power rule here, but the inner layer is this guy. This guy derivative, one derivative is 0, e to the power 2x. Derivative is e to the power 2x. Because this is 2x, not x, so you need to do the 2x derivative, which is 2. So you times 2. This equals to 2 times e to the power 2x times 1 plus e to the power 2x to the power of negative 2. Okay. Now, let's do number 13. Sign of this. You want to treat the outlier as a sign, so you do cosine of this. And then you are going to do that guy derivative. That guy derivative is e to the power of 2x plus 1. And then this guy derivative will be 2, so you times 2. Okay, that's the final answer. When we have some complicated question like this, we can use the exponential properties first. 2 times 2 is 4x minus 2. And then this. You are going to leave them as the same base. That becomes e to the power x squared plus 3x minus 2. This guy derivative will be, you copy down the whole thing here, and then that guy derivative is 2x plus 3. Okay, that's the final answer. We still have many practice. We are not going to finish because it's out of time. I'm going to upload this and make sure for this homework, every single question you want to practice and then check with my answers. Okay. All those rules combined together will not be easy. You want to make sure that you practice everything. Find the tangent line at the given point. You have to do the derivative first and then plug in the x value to find the slope, and then do the point slope format. You got the tangent line. Same thing for here. Even though this guy looks so ugly, but finding the derivative is not too hard. Do the product rule for this guy, do the product rule for this guy, okay? And you can find their final slope, a final derivative, and then plug in and use a point slope format. Okay, that's all. Let me upload the homework. I already attached the blank one. I'm going to give you all the solutions. And here is all the formula list. You want to make sure you go through all of them, okay? Yes, that's for today's class. I will upload the videos and you can check my video. Make sure you finish every single questions that I have given to you, okay? Okay, see you next week. Bye-bye.